It's like a big disgusting formula, widow's peak. What the crying I also.
No way.
So it's like a decent Is there stuff to do today?
31, 32. Hey, Cooper.
Hey.
Hey, Coop. You look like
That
Coop.
was me with the last four. It was 12 in the morning and I was like, no. And then I had to read 7 chapters just to catch up with the rest. Hey, just bring up ducks in your discussion and she'll make me do it.
Like, what do you guys think the ducks represent? And she'll be like, I love ducks. Because she was like, at least you guys were going to talk about the ducks. And we're all like, what do the ducks mean? What are we doing?
Do you want me to try this? No, he said he wasn't going to. Yeah, I got you.
Yeah, just like, they were in one page.
And I was there.
Ducks and was another thing that she really liked. I'm just going to help you guys.
The ducks and
I don't even know. There was nothing. I got nothing out of the discussion today. Except that we're really supposed to finish.
also just keep using cosmetics. Actually,
I want to tell you about this delicious dinner I made.
a mental class for the weekend. Telling me stories. Bro, I did no idea.
Yeah, she's in my
But the topic was like that. So he's actually telling this story to his
You
therapist.
weren't even lying about this.
And the whole class is like,
Wait, was it ever like that or you're just
well, it says like my man activities. Yeah. So like you were supposed to infer it.
But I feel like that's not that often.
Right. It's not. Well, and he said like you had to get away for a while. That's why. Like he was like, I had to come out here and relax. I just like didn't figure it out. How was that movie? It was last month.
Okay, good afternoon, guys. There are 2 assignments I'd like to do. The number 32 book assignment and the number 31, which was some notes that we did together. So, looks like a lot of you already turned that in, so thank you. But if you did not, I need that from you now for full points. Unless you were gone yesterday, I guess. And then you get a little extra time. A lot of people out sick, a lot of people school business. Okay, let's go ahead and get started, please. So, Unit 3, when we started that, I told you that there's a few small things to Unit 3 that we haven't looked at yet, but really 2 big topics. So one of those is implicit. So if you don't feel pretty comfortable with that after the notes we did and the book assignment we did, and I'll remind you that it's a thing on the test review, but if you feel like you're not quite there on implicit, please take that responsibility and get yourself a little bit of extra practice. But we are moving on to what's called related rates. And if I had to pick a single topic, if it's not this, it would be tied for this as far as my favorite for first semester. Just because these are some pretty interesting real world questions where we just don't need to know much more calculus to be able to do these things. So before we dive into that, all related rate questions start off with the geometry formula. So there are some geometry formulas they will provide for you, so I will do the same thing. And there are some geometry formulas they expect you to remember. So I would hate for you to miss something because you didn't remember that. So this handout, there's not a lot to fill out, but I'm reminding you that with right triangles, Pythagorean theorem is a geometry formula, so you need to make sure you remember a squared plus b squared equals c squared. Specifically, make sure c is the hypotenuse. The legs a and b are interchangeable, but the hypotenuse has to be c. For circle, you have to remember the area and circumference of a circle. Those are two formulas they expect you to know. The square is, area would be side times side, side squared, and its perimeter, if you add up all the sides, you would have 4 s's, or 4 times the sine length. Okay, and then on the last couple, I've got a couple blanks here because I want to give you kind of a tip that will help you with most three-dimensional shapes. And I don't know how common this is because I wasn't taught this in high school. I used to teach a lot of geometry when I was first started teaching, and I just kind of accidentally figured it out. So I don't know, your geometry teachers may have showed you this, but basically three-dimensional shapes, you can think of them as pyramids or prisms. Whereas a pyramid has 2 bases, a pyramid has 1 base. So something like a cone you could think of as a pyramid because it's got this 1 base. And everything that's a pyramid, well, maybe not everything, but everything that I can think of, if you need the volume of a three-dimensional shape that only has 1 base, it'll be 1/3 times capital B times H. And all you have to remember then is that capital B is the area of the base. So if it's a cone, the base is a circle, so the area of the base is pi r squared. So you could figure out, without memorizing, that the volume of a cone is 1/3 pi r squared h. 1/3 because it only has a base, 1 base, not 2 bases. Pi r squared because that's the area of its base formula times its height. Whereas something like a prism has I'm not an artist. A prism has 2 bases, 2 sides that are parallel to each other. And so something that has 2 bases, his volume is the same as the pyramids, except not times 1/3. It's capital B times H. So as far as I know, any three-dimensional shape, the volume of it, you could just find the area of the base. So for a cube, that's side times side, times the height, which for a cube is another side, or s cubed. But this little trick works for all of the main shapes at least. So let me just throw out another one just to kind of show you how I could apply this to do something like, what's the volume of a cylinder? Does anybody remember that formula? Okay. Well, let's assume nobody remembered the formula. How many bases does the cylinder have? 2. There's 2 sides that are parallel. So the volume wouldn't be 1/3, because that's only if it has 1 base. It's capital B times H, where capital B is the area of a base and H is the height. So they technically want you to know the volume of a cylinder also, but if you know this little trick, then you don't have to memorize so many. the last one I want you to add on here is, and it doesn't matter where, but sphere, which of course looks kind of like a ball. The volume of this is 4/3 pi r cubed. But go ahead and write that on your page and then put an X through it. They do expect you to use this formula a lot, but this is for whatever, I don't know their reasoning, but this is one they don't expect you to memorize, so they will always provide it on a question when you need it. So you don't have to memorize that one, but we will be using it. So I think you putting it down, putting an X through it, just kind of as a quick reminder, you don't have to know that one. Okay, so let's jump over to the related rate notes, 35. And many years ago, when I first started teaching calculus, the calculus teachers before me had a bunch of stuff typed up here. Whereas after a few years, I thought it was more helpful to kind of just take that stuff away, and we can just make the list as we go through a few examples. But this is some tips, some common strategies, so that when we get stuck on something, we have a list of things to consider or a list of things to try. Now, before I start with related rates, I need you to make a connection between this and the implicit we've talked about the last few days. So, we have been talking about if you take the derivative with respect to x. Everything we have done thus far this year has been derivative with respect to x. So just let me make a real quick example. So when you take the derivative of x stuff, you just do the power rule, and then it's like you've got dx over dx, which was like 1. Then when we took the derivative of y, dy dx, that created a y prime. Now, why I'm talking about this is it's not because this is unique to x's and y's, but really what was happening here is when you take the derivative of something like x's with respect to x, you don't need anything here. But if you take the derivative of anything else, whether it's y's or b's or r's or a's or b's or c's, whatever, if it's respect to some other variable, you have to create that variable prime. So the reason we were creating all those y primes is because we were taking derivatives of y with respect to x. I say all of that to say that the first tip I would remind myself here is that related rates, we will always be taking the derivative with respect to time. So I can't think of any questions like this, but if I took the derivative of t, well, t, taking the derivative of t's with respect to t's, those variables match up. So I would just do normal power rule and be done. But if I take the derivative of anything other than t, a, b, c, d, whatever, any other alphabet letter you want to pick besides t, we have to create that variable prime. Just like when we took the derivative of something with respect to something else, we need that variable prime. It's just that in related rates, we do everything in terms of time. Time is the thing that's moving on. Okay, so let's look at an example. Now, the nice thing about these, I will just admit, some students do think that related rates are kind of challenging, and I can kind of understand because every question sounds very different. First one's about some kind of a snowball, second one's about a stone, the third one's about a cube. Every question is completely different. But what I think makes these questions very manageable is that there are some steps. So basically knowing, always do this first, always do this second, always do this third, always do this fourth, and then maybe do this fifth. The same steps will work no matter what the question is. So let me kind of walk you through this one, and then we'll add some things that could be helpful here. So question 1, a calculus student hits his calculus teacher in the head with a gigantic snowball. I did not make this question up, and don't do that. If your snowball is melting at a rate of 10 cubic feet per minute, what rate is the radius changing when the snowball's radius is 2 feet? So if you just hope to just read that, make sense of it, and just know what the answer is, I don't believe you. I don't think you can just process that in your head and know the exact answer right away. But one thing we could do, and I don't think it helps in this question, but it will help before we're done, is we could draw a picture. So in this picture, I don't know, snowball looks like that. Okay, another thing that you need to do is gather all information. So basically, I want to organize all of these things they gave me. I don't want to reread this question 50 times trying to make sense of it. I'm going to go through and define some variables. The snowball is melting at a rate of 10 cubic feet per minute. So, snowball melting, what is that measuring? Is that perimeter? Does that mean the perimeter is getting smaller? It's the volume. Now, one hint here is, notice this, cubic feet, that's like feet cubed. Area is almost always squared units, like feet squared. Volume is usually cubic units. So they're giving me volume. It's melting, so it's going away, -10 cubic feet per minute. Now, I do think it's a good habit to put the units to, so please do that with me for the first few questions, and then you'll see why I think that's going to be helpful. Now, is this really the volume? The volume is -10 cubic feet per minute? That's not the volume. That's how the volume is changing. So it's not volume, it's the rate of volume. It's volume prime. It's the derivative of volume. Okay, what rate is the radius changing? So am I trying to solve for r? What rate?
R prime.
That's r prime. It's not asking for the radius, it's asking how the radius is changing. What's its rate? So r prime is what I'm trying to find. How is the radius changing? Specifically, when the radius is 2 feet. So I don't know. I might have overlooked something there, but you can see I kind of underlined and color coordinated everything. So I think I've used everything that they've said. Okay, next thing that you'll have to do in every single question is pick a geometry formula. Pick a geometry formula. So you can pick Pythagorean theorem if you want to, but there's no right triangle here, and there's no A, B, and C, so that would be kind of a weird one to pick. Since, based on my picture, tells me the shape is a sphere, I know something about how the volume is changing, I know something about the radius, and I want to know something about how the radius is changing. So I have to think of a geometry formula that pulls all of this together. And again, this is the one I said you wouldn't have to memorize, but you have to start with that geometry formula. And then other than a couple weeks of limits, everything we have done has been derivatives. So you need to do this. Take the derivative with respect to time. Every question, every one of these, you'll have to take the derivative. Now here's what I was trying to relate to the implicit, so that you can understand why this works the way this works. The derivative of v would be 1, just like the derivative of x is 1. But then you have to realize I'm taking the derivative of v with respect to t. If v and t are not the same variable, then it's going to create a v prime. Just like when we take the derivative of y with respect to x, y and x are not the same thing, so we create a y prime. Okay, over here, this is just power rule. I could bring the 3 down, lower the power by 1, and then I realize I just took the derivative of r stuff with respect to t. R and t are not the same thing, so you have to put in r prime also. So I drew a picture, didn't really help much. I extracted all the information they gave to me. I picked out a geometry formula that I think goes with that information in that picture. I took the derivative with respect to time, and then if you're lucky, you get to just plug these things in. So V prime is -10 cubic feet per minute equals 4, which is just a number, times pi, which is just a number, times r squared, which I know r, they gave that to me. It's 2 feet, and times r prime. So, best case scenario, you plug in the information they gave to you, and then the only thing missing, the only unknown variable, is what we have been trying to figure out this whole time in this question. Now notice, if you keep up with the units here, well, first off, this is -10, 2 squared is 4, times 4 is 16, times pi is 16 pi, so I could divide 16 pi over. But look at the units, because if you pay attention to the units, your units should help you feel better about your answer. This is cubic feet per minute. Over here, this is feet squared. So when I divide this stuff over, cubic feet divided by feet squared would just leave feet, and then there's per minute that has nothing to cancel with. And then I guess we could reduce that. 10 over 16 is like 5 over 8. And then the units should make sense. If it's a radius, it should probably be something like feet. It's got nothing to do with time. If it's radius prime, if this is in feet and that's in feet, then this should be in feet. But if it's prime, it's measuring a rate, so it also needs a time unit. If that's in minutes, this should be in minutes. But if you keep up with the units should match exactly what you have. Okay, so again, the next question is going to be completely different, but what's going to be consistent is picture might help, define the variables as necessary, pick out a geometry formula that incorporates all that, take the derivative with respect to time, plug in the given information, and then solve for what you want. So, alright, question 2. A stone is dropped into Lake Fayetteville, causing concentric circular ripples. So, some concentric circles just means circles within a circle. So, somebody throws a stone into the water, and it looks like this. We know how fast the radius is changing. So, that's r prime. We want to know how fast the area is changing. So that's not A. I don't want to know the area. I want to know how the area is changing. So A prime, what's its rate? At the instant when R is 5 meters. So, once again, the picture didn't do much for me, but between the picture, knowing I need R, knowing I need A, knowing I need R, what's a geometry formula that is this type of shape with those type of variables? Okay, so area of a circle, which is just pi r squared. And then we take the derivative with respect to time. The derivative of A is 1, just like the derivative of X is 1, but A is not T. So you either need to say, I'm taking the derivative of A with respect to time, like this, dA over dt, or you can just put A prime is fine. The right side, remember pi is just a number, so this is power rule. Bring the power down, lower the power by 1, but I took the derivative of R stuff with respect to time. R and T are not the same thing, so it's imperative that I put an R prime there. Every time you take the derivative of a variable with respect to a different variable, you have to create that variable prime, no matter what it is. And then if you're lucky, I don't know A prime, of course, because that's what I'm solving for, but 2 is just a number, pi is just a number, R was given to me, 5 meters, R prime was given to me, 2 meters per second, and this is best case scenario. They gave me everything I needed to solve for what they're asking me to find. So 2 times 5 times 2 would be 20, times pi would be 20 pi. And notice my units. Since I kept up with my units, meters times meters per second would be square meters per second, which should make sense because area usually have square units. Area is usually meters squared, inches squared, feet squared, So area prime would be feet squared per second or meters squared per second. There'd be a time element. So there's the answer. That's what they were looking for. So we need to start picking up on the consistency. Two totally different questions. Different shapes, different geometry formulas, different information. But start with the picture, figure out all the information given to us, come up with the geometry formula that ties that information together, take the derivative with respect to time, plug in the information they give you, solve for what they want to know. Okay, number 3. All edges of a cube are expanding at a rate of 3 centimeters per second. How fast is the volume changing when the edge is 1 centimeter? So, I don't know if a picture will help, but I can do a cube good enough. The sides are expanding at a rate of 3 centimeters per second. So this is how the sides are changing. So make sure it's S prime, not S. How fast is the volume changing? So what variable are they asking me to solve for in this question? Good. Not the volume, but how the volume's changing. So B prime. And you have to be told when to do this because the volume is different at different points. If the cube's really big, then increasing the size makes the volume get way bigger. If the cube's really small, increasing the side length increases the volume a little bit. So specifically when the side is 1 centimeter. So between this shape, side lengths, how it changes, volume, how it changes, and a side length. You got to think of some geometry formula that pulls that all together, like S equals, volume is side cubed. Take the derivative of both sides with respect to time, because time is the thing that's changing here. V is not t, so when I took the derivative of v, I created a v prime. S is not t, so when I took the derivative of s, I created an s prime. And then if you're lucky, you have everything that you need. I'm trying to solve for this, so v prime is going to be the last domino to fall. If I square s, that's like squaring 1 centimeter times s prime, which is 3 centimeters per second. So 3 times 1 squared times 3 would be 9. Centimeters times centimeters would be centimeters cubed, which makes sense. Volume is usually cubic units, but this is the rate of change of volume, so it does need a time component like the seconds that are there. So again, if you make a habit out of doing the units, it's nice that when you need them that you don't have to go back and redo some work. But also, again, if you understand what the units are supposed to be, it helps check your work. Like, if I forgot to multiply by this 3, I would have centimeters squared. Centimeters squared is not a unit that makes sense for v prime. Go on. Yeah. Hi. That's correct. I have it. Does she have access to a printer? Okay, I've got it on my class website, so can I email it to you? Okay. Okay, sounds good. Thank you. Sorry about that. Okay, so what I was saying is, if you forget something, like if I forgot to multiply by s prime, like if I forgot to do this, and so I didn't see this, the units would be centimeters squared, and the rate of change of volume wouldn't be centimeters squared. Centimeters squared would be like an area. So then that at least helps you figure out maybe that you forgot something. Of course, also like a lot of math questions, if it gives you some type of information, then it's probably something that you need. Okay, so for the first time ever seeing these first 3 examples, is there any consistent question that's showing up that you want to clear up before we flip over? Okay, yeah.
So all of these are rate of change, but will it ever give you rate of change if you're looking for something else?
Yes, it can. Yeah, you're not always solving for a rate of change. You could be solving for anything. So this could have been the exact same question, but instead of giving you s and s prime, they might have given you v prime and s, and you would just solve for s prime. But you still do exactly the same stuff. You would just plug the numbers in different spots and solve for something different. Okay, so other than you practicing this to get good at this, sometimes you have to do one more step. There's only one more step that could be added to these. So before I tell you what that step is, let's just see and discover what it is. So question 4, this is the most common type of related rate, by the way. I would be very surprised if you don't have one of these on your AP exam at the end of the year. I don't know why they like these questions so much, but they do. So we've got a ladder leaning against the wall of a house. Somebody pulls the ladder away from the house at a rate of 2 feet per second, and we want to figure out, for some reason, how fast is the top of the ladder moving down the wall when the base is 7 feet from the wall or 15 feet from the wall. So 2 things here. Okay, well, I have been saying I didn't think that the picture was really that necessary on the first 3, but I really think it's going to start to help in this one. So I've got a building, I've got a ladder leaning against it. Now, unlike the first 3 questions, I can't just say R equals this and V equals that, because it's describing things about this. So instead, I'm going to put them on my picture. The ladder is 25 feet long. The ladder is being pulled away at 2 feet per second. I want to know how fast is the ladder falling down the wall. So here's the ladder going down. So that would also be feet per second. This is feet per second, this would be feet per second. At the instant when the ladder is 7 feet away from the wall. So when this is 7 feet and it's being pulled this fast and the ladder's this long, we can figure out how quickly this ladder is falling towards the ground. Okay, so notice nothing's been different yet. Picture, maybe the first one is helpful. Identified all the information and threw it on the picture. So I gathered all the information that I think I need. And again, I think it helps if you underline things because it helps identify what you haven't considered yet. But anyway, so now I've got a picture, I've got some values, and just like the first 3 questions, I've got to come up with a geometry formula that ties all of this together. So what formula would you want to try? One more time. Right, Pythagorean theorem. Because this makes a right triangle. Now you could do something like the area of a triangle formula, I guess, but since we don't know area and we don't care about the rate of change of area, we don't care anything about area in this question, so that just wouldn't be a good choice. But Pythagorean theorem questions are probably the most common type, and specifically this ladder falling down is the most popular type. Okay, what did we do to our geometry formulas once we picked one out? Take the derivative with respect to time. So power rule, A is not T, so you need an A prime. Power rule, B is not T, so you need a B prime. Power rule, C is not T, so you need a C prime. In fact, most people don't even show the 2's, but you could just divide everything by 2 to make your life a little bit easier. Okay, so our first 3 examples, we picked a geometry formula, in this case Pythagorean theorem. We take the derivative with respect to time, and then we just started plugging this stuff in. Now remember, in a right triangle, I don't care what side you call A and B, but you better pick C to be the hypotenuse. So I know the hypotenuse is 25 feet. The other 2, I don't know, call one A and call one B. It doesn't make a difference. But if I call this A would be 7 feet, A prime. I need more space. I need more space if I'm going to do units. A prime would be 2 feet per second. B, I don't know the length of B. B prime is the whole point of this question, so that's going to be the last thing to be discovered. And C was 25 feet, and I don't know what C prime is. So, unless the question is super rigged, to solve an equation, you can only have one variable. If I'm trying to solve for B prime, I need to do more. This is how this question is harder than the first 3 questions. The first 3 questions didn't have this as a problem. The first 3 questions, we plugged in what we had, and then the only thing missing was what we wanted to know. This time we plugged in all the information given to us, and there's still 1, 2, 3 things I don't know. So I have to dig in a little bit deeper and figure out what is B and what is C prime. So what does C prime represent in this question? Okay, and how is the ladder changing size? It doesn't change size. It's 25 feet the whole time. So this, we really know is 0. The length of the ladder is not changed. I mean, I guess, you know, some ladders do retract and stuff, but that's a whole nother thing. The ladder is not changing. 0 feet per second. That's a 0. Okay, so even piecing that in, we still have to figure out B before we can solve for B prime. Well, there's a lot going on here, so let me redraw it real quick. If we just focus on the right triangle, and I know this length is 25, and at the instant that we're working with, this is 7 feet, you could find this side, you could find the length of B with Pythagorean theorem or with Pythagorean triples, if you know Pythagorean triples. So this would be a 7, what, 25? Very good, 24. So, or you could just do Pythagorean theorem. You could do the square root of 25 squared minus 7 squared. So, again, it's kind of hard to see that when you've got too much mess going on. That's why the bigger your picture is, probably the easier it is to see. But I'm just trying to focus. If we know this length and this length, we can just do Pythagorean theorem to find this length. So, this becomes 24 feet. And now it's just a matter of solving for B prime. We've got an equation, that's the only thing missing. So here we've got 14 square feet per second. Minus 24 feet times B prime equals 0. Can subtract this over. Undo times with divide. Okay, and then units, feet squared divided by feet would just be feet. And I've got it per second that didn't combine with anything, so my answer is in feet per second. And then my answer comes from negative 14 over negative 24, which is like I don't know. Yeah.
How did you get the negative 24? Like, how did it become negative?
I don't know. I was trying to read this. I couldn't read my work here. I was too focused on the 1. Oh, this is a plus.
Okay.
That's why. That's a plus. So that's a plus. So that's a plus. So negative 24 divided by positive, negative 14 divided by 24 is negative, divided by 2 would be 7, divided by 2 would be 12. So negative 7/12 feet per second. Now, by the way, what does that mean, the fact that that's negative? Okay, good. So this is a speed like a velocity, and when velocity is negative, it's going down. Doesn't that make sense with the problem? Isn't the ladder going down? So it makes sense that the answer should be negative. If it was positive, it means it's going away from it. So okay, and then so we are not going to redo this question, but let's focus on what would be different if it had just been 15 feet from the wall instead of 7 feet from the wall. So again, we're not going to redo all of it. We're just going to go through and talk about what would be different. If this was 15, I would still have same geometry formula, same derivative. C prime is still 0. But if I change A to be 15, don't change A prime. Do you see how that's going to affect your B and your B prime now? How it's going to change those two numbers? If this goes from 7 to 15, now Pythagorean theorem, 25 is the hypotenuse, 15 and I think 20. Does anyone know? Okay, I don't know my Pythagorean triples very well. So if I change this length to 15 from 7, that changes this length to fit Pythagorean theorem to be a 20, and therefore B prime would be -3/2, -3/2. But everything else would be the same. But if I change one length, it changes another length, and if the lengths change, then the rate of change would change also. Okay, and finally, is everybody done with that? Okay. Okay, one more example, and then okay, we're not gonna make it. We can't. I don't want to rush through it. I do want you to fix one quick thing on here though, and then we'll find a stopping spot. I didn't make this question up, but somebody was thinking ahead a little bit. It's supposed to say a baseball diamond is 8,100 square feet. It's supposed to tell you the area of the baseball diamond. Okay, so tomorrow we'll do this baseball question where we can figure out how fast somebody is moving away from home base. If we know how fast they're moving away from first base and know how far away they are from first base, that'll finish up our notes. And then the other handouts you picked up, we will start practicing some of these so that we start moving in the right direction. But we're out of time today, so just have to call it quits there. I obviously did not have time to get your homeworks in gradebook and back to you, so I will do that this afternoon or tomorrow and put your graded papers away in your folder. So